and welcome to Research Strategies. Today we're going to be talking about experiments. Here are your learning objectives, and here is your vocab. Pause where you need to. So what is an experiment? This is a research method where the researcher is going to manipulate and control certain variables and try to see if one causes another to react. So why would we conduct experiments in psychology? Well, the only way that you can see cause and effect between two things is to conduct an experiment. So there's a lot of reasons. That's a big reason. So a hypothesis, I'm sure you're familiar, is a testable prediction about the outcome of your experiment. So in order to create a good hypothesis, a good research experiment, and a good research experiment can be replicated. So in order to do that, one must operationally define all of the variables. So for example, if students are assigned to listen to music each day in study hall, and the hypothesis is that those students assigned to listening to music are going to have a higher GPA at the end of the term than students who are not allowed to listen to music. Well, you're going to have to operationally define how much they are listening to music, right? So your control group isn't listening to music, but how much and what kind of music and how loud is it? Like those are all important factors so that your study could be replicated and so that other people can interpret your findings clearly. So the independent variable is the one that it would be the cause. This is the one that the researcher is manipulating or is changing in order to hopefully see that the dependent variable is being affected by it. So there's some sort of change in the dependent variable because of the independent variable. All right, so in an experiment, you have two groups. You have an experimental group that receives the independent variable, and you have a control group. So in our case of the study hall and music listening, the experimental group would receive the music. They would be the one exposed to that independent variable of music listening. Our control group would be the ones who are not allowed to listen to the music. So the control group is the one that kind of serves as a comparison, because if they do just as well on these tests that they're taking as the music listening group, then we know that the music wasn't really the factor. So how do we decide who goes in what group? So the best way is random assignment, and this is a procedure that creates the groups random to make sure that it's at random. You can't pick everyone from like one class, right? Like one section of Psych to be in the experimental group and another section of Psych to be the control group. That is not random. Perhaps the kids who are taking a harder math class or whatever are in a different block, and those students are better at multiple choice type questions, and the test is a multiple choice. Like there's so many other confounding variables that wouldn't be a good control group. So you have to use random assignment to protect against confounding variables. So a confounding variable is any variable that could cause the change. So it could change the test scores, and it wasn't like, let's say, the music in our first example. So anything that can confuse our result. Controlling for the confounding variable, we can also use a double-blind procedure. This is where both the researcher who is conducting the experiment and collecting data and the participants in the experiment are not aware of who is receiving the independent variable. So an easy example of this is with a medication. So let's say that you were testing an ADHD medication. The researcher who is collecting the data, deciding or tallying how often the individuals are paying attention or whatever they're supposed to be on task, they don't know who has the real experimental drug and who is in the control group. And the participant doesn't know. That way you don't get participant bias where they start acting better because they took the medicine, because that's a thing, right? That happens with the placebo effect. And that's when, so the control group in this scenario would be given a placebo pill. It's a sugar pill. It won't actually, according to the hypothesis, it's not going to do anything, right? But we need that because just taking a pill and saying, okay, now we're going to give you these attention tests, the person might experience the placebo effect, where they actually pay attention better because they think they just received medication that improves their attention. The placebo effect is powerful. So the only way to protect our results against that and see if the medicine actually works and it's not just placebo effect is to use this double blind. So in looking at our data, we want to look at our results in any study that you see. If they say the results are statistically significant, this means that the possibility that the results of the experiment happened by chance, right? Like they ended up this way, the music did seem to cause better grades. But if the data is so strong, and we're saying statistically significant is less than 5% chance that the results are because of chance, like because of some random other factor. That is really a strong statement, and so we say that the results are statistically significant. That just basically means the results are really strong or really good, that this might really mean something. Maybe music really, it doesn't mean, the results of a study never mean, yes, 100%, this means that listening to music will improve your scores. It just means that, wow, this is really, there's strong data here to suggest that music causes better grades, music listening. And obviously, in any good study, we would need to be able to replicate the study. So making sure all of the variables are clearly defined and it can be replicated. And the more something can be replicated and the same results keep happening, the more we are likely to believe that this is really seems to be true. There's been a lot of studies done on listening to music while studying, and there's a lot of data to show that it does actually help. So replication is important for that. So takeaways. Remember that experiments are important because the only way to see a cause and effect is to conduct an experiment. It's important to operationally define all of our variables. So when we come up with that hypothesis, make sure that everything is clearly written out so that our study can be replicated. There are some things that can confuse our results even when we're being careful at times, and this is a confounding variable. So in our music example, it could be the time of day that the students were taking the test was not ideal, from their pre-test to their post-test or something like that. Remember that the independent variable is the cause, is the thing that the experimenter is controlling and manipulating, and the dependent variable is the thing that they are measuring, or it's the thing that is the effect. In order to make a good experiment, a researcher should randomly assign participants to either that control group or the experimental group. And a double-blind procedure also protects from a bad research study because it can take away the placebo effect and any sort of observer bias that the researcher might have. So that sums up Mod 3.7, and I will